Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Every year, a silent miracle unfolds across our planet. Billions of tiny organisms, weighing less than a paperclip, embark on epic journeys spanning thousands of miles. From the monarch butterflies of North America to the Bogong moths of Australia, these migratory insects navigate with a precision that rivals our most advanced military-grade GPS systems. But how do they do it? While we have long known that creatures use the Earth's magnetic field, the position of the sun, and the patterns of polarized light, a radical new hypothesis is emerging from the intersection of biology and astrophysics. This is the story of the pulsar compass, the theory that migratory insects might be using the rhythmic whispers of dead stars to find their way across the globe. To understand this, we first have to look at the navigational challenges these insects face. Imagine being a Bogong moth, flying through the pitch-black Australian night toward a specific set of caves in the snowy mountains that you have never visited before. You are tiny, the wind is fierce, and the terrestrial landmarks are invisible. Traditional celestial navigation using the Moon or the Milky Way is helpful, but these sources change position or can be obscured by clouds. This is where the concept of pulsars comes into play. Pulsars are the highly magnetized, rapidly rotating remnants of massive stars that have gone supernova. They are, essentially, the cosmic lighthouses of the universe. As they spin, they emit beams of electromagnetic radiation that sweep across space with incredible regularity. Some pulsars rotate hundreds of times per second, creating a signal so stable that they were originally mistaken for alien beacons. For a human, these signals are invisible without massive radio telescopes. But for an insect, the world might look very different. The key lies in a field known as quantum biology. Recent studies into insect eyes have revealed the presence of proteins called cryptochromes. These proteins are sensitive to blue light and are thought to be the engine behind magnetoreception, the ability to perceive magnetic fields. Scientists have discovered that cryptochromes operate through a mechanism called the radical pair mechanism, where fleeting chemical reactions are influenced by incredibly weak external magnetic or electromagnetic forces. This is where the pulsar connection becomes fascinating. While the radio waves from a pulsar reaching Earth are faint, they possess a rhythmic, low-frequency pulse that is unlike any natural terrestrial signal. It is hypothesized that the highly sensitive neural pathways of migratory insects could be tuned to detect these subtle, rhythmic fluctuations in the cosmic background. Unlike the sun or the moon, which move across the sky, a pulsar's position in the galactic frame is essentially fixed on a biological timescale. If an insect could perceive the timing or the specific frequency of a pulsar, it wouldn't just have a compass, it would have a galactic clock. This would allow the insect to triangulate its position with startling accuracy, regardless of the weather or the time of night. The implications of the pulsar compass theory are profound. It suggests that life on Earth is not an isolated phenomenon but is deeply integrated into the fabric of the galaxy. It implies that the evolution of migration was not just a response to local climate, but a grand adaptation to the cosmic environment. Critics argue that the signals from pulsars are too weak to influence biological systems, but nature has a habit of proving us wrong. We once thought birds navigated by sight alone, only to discover they have quantum sensors in their eyes. We once thought insects were simple machines, only to find they perform complex spherical trigonometry mid-flight. As we develop more sensitive instruments to measure the electromagnetic environment of our planet, we are beginning to see the world through the eyes of the moth. We are realizing that the night sky isn't just a beautiful backdrop, it is a complex map of data. Every flicker of a distant star, every pulse of a neutron star thousands of light years away, might be a guiding light for a traveler no bigger than a thumbnail. The Pulsar compass challenges us to rethink the limits of biological perception and the scale of the natural world. It reminds us that even the smallest creatures are children of the stars, navigating the terrestrial wilderness using the heartbeat of the cosmos itself. As we continue to bridge the gap between the study of the very small and the very large, we may find that the secrets of the universe are written in the flight paths of the humble insects that share our world. For more incredible facts like this, don't forget to subscribe and turn on notifications.